Well, thank you everyone for logging on this morning. We appreciate all of your attendance. So this is the second IAFSM YP Group Webinar. Thanks for those who came back from listening to our first webinar. Hope that was informative. I think this webinar will be really interesting, and we've got two really good speakers, Brian Chaille and Chris Hanstad. Both of them work for the Illinois State Water Survey down in Champaign, and they both have a lot of experience with working on LOMRs and using HEC-RAS 5 RAS mapper tools. So they're going to talk through some of the recent updates and how you guys as engineers and consultants and officials can use some of these tools to help improve your processes and improve the submittals to make them a little bit easier for them to review and get everything going a little more smoothly. Just a few administrative things. For everyone that's attending, we will send out one PDH certificate. Goal is to send that out sometime later this week or by the end of the week. And we'd also appreciate them to send out a survey just to get some feedback. Any feedback that you guys have on any future webinars or any comments are definitely helpful. Just an FYI, this is the webinar itself today is a recorded video. This is just done to make sure we didn't have any technical issues. So as far as the way that this webinar is going to work, I'm going to pass to Brian. He's just going to do a quick introduction on a few topics. Then I'm going to play the video live. And if you have any questions during the video, please submit them through the group chat to everyone so they could see it. If it's a question that can be quickly answered, Brian and Chris will try to provide you with an answer. If not, we can hold it to the end of the session and they could give a more complete answer, but we will make sure to get to any questions you have. Just want to keep things going and be easier this way. So without further ado, I'm going to pass stage to Brian and he's going to kick it off. So go ahead, Brian.
Thanks. I just wanted to say first how much I appreciate the young professionals group. I think it's a real asset to IAFSM overall, and it's just a great venture. So thank you, Adam, for being part of the group that initiated that. It just really, I think, means a lot, and I think adds a lot to all of us. You know, it's a good way to get so many younger professionals involved in IAFSM, and that has just been such an important part of a lot of our careers, both professionally and personally. And there's so many deep friendships that people have developed over the time as they work together, and it really is a pretty small community, and we rub shoulders with each other all the time. So it's just a real good that we're starting as early as we can. I'll get started. This is going to be a little humorous for those of you that have had ongoing CLOMRs for a year or better, but we're titling this How to Get Faster CLOMRs. And I've got I'll try to pull that down. Let's put this somewhere else. All right. This is a really happy guy, if you can see my screen. He's the first one across the finish line, and he's fast. And you young professionals, by nature, pretty fast people. But there's an important thing that he needs to do. He needs to stay within his lines. He needs to run a good, clean race. And before we get into how to go really fast, we are going to talk a little bit about what the course is and how to stay within those lines. Hello. There we go. So this is the course overview. This is this is the basic elements that are probably most essential to speed the process of getting a LOMR. Aside from Endangered Species Act requirements, which can be a real, can really slow the whole process down, but we're not going to talk about any of that. What we're going to talk about is just these basic elements. On the left-hand side are the incremental changes that are allowed between these various types of models that are required. Of course, the whole thing starts with the effective FEMA model. That's the model that has become a regulatory product. And when we say effective, that's a strict definition. It's the model that is currently effective. You have to duplicate that effective model with as minimal changes as possible to create a comparable profile within certain tolerances. If you're using, and we'll go into more of that. I just want to go over the overview right now. The corrected effective model allows you to make corrections if there are errors in that original analysis, and virtually any valid change is allowed, and that may make feet of difference. Between the corrected effective model and a pre-project model, you're limited to some regulatory requirements, and as well as you go to a post-project model. But this is the overview. There are a certain set of approved models for FEMA, but they are relaxing on that. We approve models anywhere from ICPR, which is a pretty, not a very widely used model. We've approved SWIM models. They're a pain in the butt. DuPage County has FEQ, that whole thing. Those are going through the process. But really, the whole map revision process revolves around RAS. It just does. You get your approved models, your effective models from the engineering library, and there's a couple of links for you to be able to pick up. And there's those 4 basic required models that we're going to go into detail. The quickest way to break a model is to do file manipulation outside of RAS. If you're using RAS, that's a good way to make sure that your model doesn't run for us. So let's go into the duplicate effective model. 2 big points here are, if you are using the same original platform, say the model was done in HEC2, and you actually have an executable HEC2 file, which is possible, it's possible to get really, really close agreement then, maybe perfect agreement. The requirement for going platform to platform from the effective model to the duplicate effective model, if you're using the same platform, is 1/10 of a foot. If you're changing platforms or you're developing a completely new model just to duplicate the original profile, that requirement is within 1/2 a foot. Sometimes those differences can be used to your advantage. The corrected effective model is simply that. It's intended to correct for errors in the duplicate effective model. You can add cross-sections to improve those results, but they have to be based on detailed historic topography. It may be something as simple as showing through an analysis of available aerial photography that there haven't been any significant changes within that topographic area, and a current DEM is still valid. But some evidence of that is necessary. You may have to go back to old contour maps and figure out how to get that information into your model. That's not we're going to cut to the chase on what we're doing now. The important thing is that there can't be any man-made changes in the corrected effective model from the date of the effective FIS. A lot of times the model was done a couple of years before the FIS went into effect, and changes since that time are grandfathered. You can go back and add those changes in without causing any problems to the community overall. I mentioned the problems that you might cause to the community when we talk about pre-project conditions model. I'd rather you use the word pre-project because that's a definitive point in time. When you say existing and you are in a LOMR phase, you mean prior to the project. When you say existing in the post-project phase, I don't know what you're talking about. So that pre-project conditions model, that's when you're going to say, well, these changes have occurred since the time of the effective model, and here's their impacts. That may or may not result in a violation to the community. It's possible at that point, and that's one of the things that we are looking for, is to be able to flag a violation, because violations can put a hiccup in the whole review process. It's much better to address those violations clearly and concisely at the front end of the project so that we can send the appropriate reports up to FEMA and allow FEMA to make that decision on a potential violation. So the other things that you can include in there, and it's possible that you may have equivalent models. The duplicate effective model, if there are no changes, may be fine, and it may be equivalent to the corrective effective model. If there haven't been changes since the time of the FIS, the pre-project conditions model may be the same as that duplicate effective too, and you're just looking at what the project is going to impact. The post-project conditions model is, what is your project actually doing? How is it affecting the results of the analysis in that particular area? So that's a lot of models, and it's kind of confusing sometimes as why we're doing these. Basically, we're trying to isolate the changes between the different things so we know where to allocate. This portion of the change is due to this portion of the change is due to that. We are looking for potential violations, but that's not the only thing. You want to try to isolate, if you're looking at a LOMR for some project, saying this project only has this impact, and that's part of the whole process. So it ensures first from the get-go that you've got the right model and that you've transferred that data correctly. And that allows us then to better integrate the overall analysis into the larger database that we have to integrate it into. We're looking for comparisons between all these different areas. And sometimes they will require certain steps be taken. For example, if you have an encroachment into the effective floodway and that causes any increase at all, in the LOMR phase, there's a process to deal with that. And it falls under the area of the regulation called 44 CFR 6512, and you'll hear us talk about 6512 sometimes. And there's a certain set of requirements that have to go along with that, including notifications to property owners of the specific impact to their properties. So now we will transfer over to Chris, where he is going to show you awesome stuff. That was the boring part. Now you get to see Chris's cool stuff. If I can give him the screen back. Stop sharing. There we go. All right. Chris, you're up. Sorry, that took a little bit longer than 10 minutes.
Okay, we're going to walk through a quick demonstration using RAS Mapper to develop a duplicate effective, corrected effective, and a proposed conditions HEC-RAS model. With HEC-RAS 5.0, which introduced 2D modeling into the program, there were many substantial improvements to the RAS Mapper feature to accommodate 2D modeling, which also benefited the 1D modeling as well. But the features for 1D modeling were still primarily limited to enhancing the viewing of 1D results. With HEC-RAS 5.4, which came out about 2 years ago, RAS Mapper was equipped with the ability to generate 1D model input. So if anyone's used HEC-GeoRAS in GIS, RAS Mapper was essentially starting to replace GeoRAS. And this is really beneficial to modelers because it gives us the ability to set up a model quickly, see our results almost instantly, and make changes without having to go back and forth with these separate programs and processes. So we're going to get set up here with an example model that we're doing in HEC-RAS here, and I'm going to be using HEC-RAS 507 for this example. And if you've never used RAS Mapper before, there's a couple ways you can get to it. You can get through the GIS tools here on the main window, or this icon right here. So once you select that, the RAS Mapper window is going to pop up, and it's formatted somewhat kind of like a GIS type environment where you've got your layers here to the left, and you'll have your main viewing window for all your spatial data will appear here. First thing that we want to do is we want to add projection, spatial projection to our model to get things set up. So as a best practice, what's beneficial to do, or what you should be doing, is if you've got a projection file, in this case we're going to be using state plane east, it's a .prj file. It's always good to make a copy of that and put that in your HEC-RAS folder directly, as opposed to referencing it somewhere that's saved locally. And the reason for that is then if you transfer your model or send your model to IDNR, Water Survey, someone else, when they open it, they'll have that projection file with them if it lives in the directory. So you want to add a copy of your projection file to your HEC-RAS folder. And then when you go back into RAS Mapper under Tools, it's going to ask you to set projection for the project, which is really the first thing you need to do before you start building any data into RAS Mapper. So we're going to open up that projection file that we just copied in there. It's got the projection information here. There's a few other default settings that you can mess with, but for now we're going to leave those as default. And then once you've set your projection, you can start bringing in data into RAS Mapper. And the first thing we're going to do is we're going to bring in our terrain data set. Now we're fortunate in Illinois that we have LiDAR coverage throughout the entire state. So anywhere in the state you can get high resolution topographic data. This example project is in Champaign. That LiDAR was acquired back in 2008. So we select this ADF file. And in RAS Mapper allows you to bring in multiple terrain sets. The thing that you need to be aware of is that whatever terrain set sits on top, that's what's going to be the priority terrain for the blended terrain surface that RAS Mapper is going to create. So if you've got a small project site terrain that you want to bring in, just make sure that layer sits on top so that it's what will take precedence over the rest of the topography. And then you can set the name for your terrain. I'm just going to call this 2008 LiDAR. And then it'll take a few seconds here to create that terrain layer. And here we go. There's a few ways to view this in RAS Mapper. If you right-click that layer, you can display image properties. You can have it update per the screen, which means that that color ramp will change depending on where you are zoomed into, so you can get more resolution if you need it. Generally, I find that I don't need this and I just keep it turned off. You can plot contours, which I always find to be helpful. You can go all the way down to a 10-foot if you need that. Most of the time you don't. 2 foot is probably good for here. I'm going to keep that turned on in a second. And so right now we've got our terrain. We're going to be looking at an area here where we're going to develop a model, and we're going to be developing a duplicate effective model here in a minute. But first I'm going to add a few more layers in here. You can add web imagery into RAS Mapper. You've got your choice of these selections here. I tend to prefer Google Hybrid, but you can choose whatever works for you. It's going to show up under this map layers here. And once you turn that on, it's going to completely block out your topography. So you're going to want to go to your image properties for your map layer there, and you're going to want to set the transparency about halfway so you can see your terrain still through all this. You don't have to use the aerial imagery. It's just one thing that I like to use when I'm doing modeling so I can see what I'm looking at. And we're also going to add in the effective floodplain maps, because Champaign County has digital floodplain maps, as does most counties in the state of Illinois. And because we have got digital floodplain maps, we can bring in some features like the floodplains. Also, we can bring in the water lines and the cross sections that are loaded in the database. So we're going to add in map layers under tools. And this folder right here, this is the NFHL National Flood Hazard Layer download from FEMA for Champaign County. And you can download, or you can add in any one of these spatial layers into RAS Mapper. So I'm going to start off with the water line. And it's kind of hard to see with the contours on, so let me turn that off. So we got our water line here. This is the saline branch. We're going to add in our cross sections. So you can see these are our cross sections here. We're also going to add in one more layer. I think we'll add in the flood hazard areas. So this is going to show us a few different things. Without seeing the actual map, it's kind of hard to tell, but this is the floodway here. This is going to be the 1% annual chance floodplain, and this is going to be the 500-year floodplain. Actually, I might take this out and do the flood hazard lines instead, so I'm going to remove that. Okay, this will be a little bit easier to view. Next thing we can do is we can actually label these features that we've added in. So for the cross sections, for instance, I'm going to open up the layer properties, and I can label these features, and I can label them with any number of the attributes that are listed in the layer attribute table. I want to label the cross-section letters. I also want to label the regulatory BFE. So I'm going to select those, and then what we should see here, I want to bring my aerial photography underneath all the other layers, so I can move that down to the bottom, and that should make it a little bit easier, yeah, to read this. So we got cross section S, which has a BFE of 714.5, cross section R, Q, P. So we have that all loaded into RAS Mapper right now, and we're able to see this data that we have, and now we're ready to create our duplicate effective model. Okay, the first thing to do to create the duplicate effective models, we need to create a geometry file, which we're going to call our duplicate effective geometry. You can do that either through the HEC-RAS main window, or you can do it here under RAS Mapper under geometries, add new geometry. I'm just going to call it duplicate. And it's going to create all these layers under that new geometry that you added to RAS Mapper. It's going to create a rivers layer, cross section, a few others. Most of these have to do with the 2D modeling, so primarily we're going to be working with the rivers and cross sections for a 1D model. But we're going to select the rivers layer first. We're going to create our water line, and the way to do that is you're going to select over your river layer, you're going to select edit geometry, and then you can either draw in your river layer by hand like this, but since we already have a water line from the FEMA database, we're actually going to use that instead. So what we're going to do is we're going to turn off some of these other layers here first. Let's turn on, we'll keep our terrain turned off. And then we're going to select our water line here. This is the saline branch. This is what we're interested in modeling. Once it's highlighted pink, you can right click on it, copy selected feature, and then we're going to highlight over the rivers layer in the duplicate effective geometry. And then you can either right click on that and then paste features from the clipboard, or you can go up here to tools and then paste that one feature that you have copied to your clipboard. Either way it'll work. And your waterline shows up there. It's the same feature that was in your other FEMA database files. And the first thing we want to do is we want to make sure that the waterline is oriented correctly. If you're going to draw in a waterline, it needs to be drawn from upstream to downstream. And in this case here, the same branch flows from up here all the way downstream is in this direction. So when you bring in a copy layer, you really want to make sure that that line is recognized as being drawn from upstream to downstream. So the way to double check that is to right click on your river layer, layer properties, and then you can select the directional arrows. And then if you zoom out to the ends of your water line, you should be able to see which way it's drawn. And you can see from here that this water line is oriented incorrectly from downstream to upstream. So if we were to bring in cross sections, try and draw in cross sections, try and do modeling, we'd get all the way to the end and try and run this model, and it wouldn't work because it would be recognizing the water line isn't oriented correctly to have the model run. So fortunately we can fix this. The way to do that is we're just going to simply, not going to do that, cancel that. We are going to just select the water line, right click, and you can select reverse selected line, or you can go up to tools and reverse feature. Either way, as soon as you do that, that water line is now oriented from upstream to downstream correctly the way that we want it to. So that's a very important step that you need to make sure happens in order for your models to be working. You can right click, open the attribute table. We can give this river a name. We'll give it a reach name. We're going to call it Saline Branch. And should update, yep, it should update the water line name. We're going to zoom back into the area that we're interested in. And now that we've got our river, our water line in, we're going to want to bring in the cross sections as well. So we've got cross sections P, Q, R, and S. These are the effective cross sections that we want to bring into our duplicate effective model. So again, rather than drawing these in by hand, we can bring them in from the S cross sections layer from the FEMA database. And we're just going to highlight that, and we're going to select an area that encompasses all four of those cross sections. Once they're pink, they are highlighted, selected. We're going to copy those, and again, we can come select the cross sections layer, right click, and then we're going to paste our features from the clipboard. And there we go. We've got our four cross sections into our duplicate effective model. You'll notice that RAS automatically assigns river stationing to these cross sections based on that water line that you've put in and the spatial projection and whatnot. But right now, these cross sections, it's pulling its information from the only terrain data source that we've given it, which is the 2008 LiDAR. But in order for this to be a duplicate effective model, we need to override that data with the cross-section data from the regulatory HEC2 model. So what we're going to do now is we're going to save what we've done, save our edits, because we've got our waterline where we want it, we've got our cross-sections where we want them. So the only way to save your edits in RasMapper is to stop editing, and then it's going to ask you if you want to save your edits. Of course, we do. So now we're going to come back to the HEC-RAS main window, open up the geometry editor, and then open up our duplicate effective model. I'm going to zoom in here to the area that we've been working, open up our cross sections, and again, what you're seeing, in these cross section lines that we cut, this is the 2008 topography represented in those cross sections, but we want to put in the regulatory model, the HEC2 model cross section information into these cross sections. So I've already gone ahead and extracted that HEC2 information from this model. We want to make sure that we're working with the right cross sections. So if we go back to RasMapper here, you can see that this upstreammost cross section, this is cross section S. So I've got my data for cross section S right here. And I want to make sure this is at the upstream-most cross-section so that we're working with the right cross-section locations. We're going to copy the station elevation data from HEC2, and we're just going to paste that in to our cross-section. Now when you do that, it's going to tell you that it's recognized that the endpoints of the cross-section have changed, and it's going to ask us if we want to adjust the cut line. And for now, we're just going to say, no, we don't want you to change the line. We just want you to accept the new cross-section data. So we're just going to accept these edits and leave those alone, the lines alone. And it's going to tell us that the bank stations are not located in this cross-section either, because we've changed the station elevation data. So if we do a full plot here, you can see this is showing us a projection of the 2008 LiDAR on that cut line and the cross-section data that we've given it from the HEC2 model. Now, the cross-section appears to be shifted a little bit, but otherwise it looks like it's a pretty decent representation, at least of the channel, for this cross-section in the model compared to the 2008 topography. But we want to feed this only the effective model, so we're going to override some of this information with information from the HEC2 model. So we've got our reach lengths, with which the RAS mapper thinks should be 1724 feet. The effective model says it should be 1730, so it's actually pretty close. Some models can be, some of the effective models can have really significant errors, but this one appears to be in pretty good shape. Either way, we will put in the effective values here. We're going to put in the effective Manning's values so that we're looking at a fair comparison. And we're going to give it the bank stations that were in the effective model. So for the left bank, that's 1,000. Right bank stations, 1083. We'll apply that data, and that looks good here. So now we're going to do that to the next cross-section downstream, which is cross-section R. So same thing. Copy that station elevation data, paste that in, set that data, but leave the cut line alone. You can see why I only chose an example of 4 cross-sections, because this would have taken a while if I did any more than just 4 for the purposes of doing a demonstration. We want to override our reach lengths here. RAS mapper thinks the reach length is about 1245. The effective model is 1200 feet, so again, pretty close, not too bad. We're going to use the effective reach length. And we're going to use the effective bank stations, which is 217 and 330. Apply that. Looks pretty good. Go down to the next cross section, do the same thing. Apply that data. Leave the cut line alone. We're going to update our reach lengths. So about 1,300 feet here, about 1,230 in the effective model. So a little bit of a discrepancy there, but overall not too bad. We want our bank station 260 and 351. And then last cross-section P, station elevation data. I'm going to leave our cut line alone. We don't need reach lengths for this cross-section because it's our downstreammost cross-section, so we just need to update it with the bank stations. And there we go. So now we've got our effective geometry in our duplicate effective model. So the next thing we need to do is we need to, well, first what we should do is we should save those changes so we don't lose those. But now, next thing we're going to do is we're going to create the regulatory flow file. So we're going to have 4 profiles that we're going to be modeling here. We are going to name those. We've got our 10-year, 50-year, 100-year, of course, 500-year. And we're going to use the flows from the regulatory model, or the FIS. So for the 10 years, 2500 CFS, 50 years, 3560, 100 is 4000 CFS, and the 500 years, 4900 CFS. Last thing we need is we need the boundary conditions, and we're going to get that from our downstreammost cross-section. So we've got our starting moor surface elevations here for the 10 year, it's 709.9 feet, 50 year, 711.4, 100 is 712, and finally the 500 is 713.2. Okay, now we're going to save this flow data as the regulatory flows. Okay, now we've got the regulatory flow data, the effective geometry. We have everything we need for our duplicate effective plan. So we're just going to save this as our duplicate effective plan. And with any luck, we'll be able to run this model. Success. All right, so now we're going to go back to RASMap and we're going to actually be able to view those results, which again is one of the handy features of the new RASmappers. We can instantaneously view our results as soon as we've run our model. There's a couple ways to view your results. I like the depth grid. It shows me a lot of information. I like the way it looks visually. And then adjust the transparency down. But when you select on the layer, you can use this scrolling bar up at the top to change the frequency that you're looking at. So we're again going to be interested mostly in the 100 year. And right off the bat, let's go ahead and compare that to our S flood hazard lines. And what we can see if we zoom in here a little bit is that we actually look pretty good. The 100-year depth grid is pretty closely following this 100-year flood hazard line. Again, this is floodway here. This line is the floodway. Here's the floodplain, 100-year floodplain. And so it doesn't look too bad. So it looks like we've got a pretty good representation of the effective mapping to model at this point. I want to show you a few things here with the RASmapper output from the results. You'll notice if I turn on the terrain, you'll see areas where you get some straight lines on your floodplain that don't seem to really follow the topographic information, like here, here, a little bit over here. And what's happening there is RASmapper will delineate data based on your edge lines and an interpolation surface. So if I turn this off, these are the edge lines. They more or less connect the ends of your cross sections, but you can see that we have areas that would extend outside of these edge lines that don't have any mapping, and it just terminates there. Those edge lines kind of create the boundary for the interpolation surface. So in RASmapper, it will interpolate an elevation between two cross sections based on this interpolation surface, but it only extends out as far as those edge lines. So what we want to do is we want to go ahead, for mapping purposes, we want to edit these edge lines, and we can do that by double clicking on them, and we're just going to pull them out a little bit further so it captures more of the terrain data that would be inundated. And we got this one other area here. Pull these out. Now we're just going to save that. And we're going to rerun the model. And what it should do is it should, see that? It updated the results, and now that mapping is fully extended out to these natural extents of the floodplain based on the topography. So that's just one thing to keep in mind, is you want to make sure your edge lines are extended out far enough so you can capture all the mapping. But what we really want to do with the duplicate effective models, we want to make sure that it's closely representing the effective model results. So even though it looks like it compares pretty well graphically, the FEMA requirements is that the duplicate effective model has to match the effective model results to be within a ½ foot at every location. So what we're going to do is we're going to grab our elevations from the HEC-RAS output profile output table. We're going to copy these results, and in my spreadsheet here I've already set up a comparison table. So we've got our effective HEC2 elevations here. We're going to paste our duplicate effective results here, and we're just going to let that compare it, and we can see that everywhere we've got a comparison. The elevation is within half a foot of the effective model. So our duplicate effective model meets the requirements for a LOMR based on FEMA's requirements, so it's good to go. And now we are ready to start on our corrected effective model. So to create the corrected effective model, what we're going to do here is we're going to come over to RAS Mapper. We're going to select over our duplicate effective geometry, and we are going to save geometry as. We're going to call this corrected effective. And that will effectively make a copy of that model. And what we can do is, turn on some of these layers. So it's basically giving us these same cross sections and water lines that we had in our duplicate effective model. But now what we want to do is we want to actually introduce the additional cross sections in this model. We want to introduce any corrections that we might need to. We're going to certainly update these cross sections with the newer topography and the newer reach lengths. So first thing we're going to do is we're going to draw in some additional cross sections here, because you can see while the cross-section spacing may have been appropriate for the time, you can see that there's areas where you get a little bit of a pinch here in the topography that isn't really reflected. It's wider here, and then again it becomes very constricted very quickly here. So adding more cross-sections will help capture those changes to the terrain that we want reflected in a corrected effective model. So we're going to go to the cross-sections layer under the corrected effective geometry. We're going to select Edit Geometry. And here we're actually going to draw these cross sections in by hand. And one thing we want to make sure is our cross sections are oriented from left to right over bank. So again, like with the river line, we can select our directional arrows and see that the cross sections, the effective duplicate effective cross sections, are cut from left to right. Once the river line is oriented properly in HEC-RAS, it doesn't matter which way you draw those cross sections. They're going to still show up from left to right, and I'll illustrate that here as we go through. So I'm just going to add some cross sections. Normally we cut from left to right bank here, and I'll do some of those like standard, and then I'll do some with cutting from right to left bank, and you can still see that it shows up oriented from left to right. So I'm just going to add some more cross sections here. Don't judge me for my quick and dirty cross-section placement here, but what I want to do is I want to get some more detail into this corrected effective model. And so I'm just going to add a bunch. We want to capture this area where the flow is becoming really constricted. It's getting kind of tight. Just going to add in enough cross sections to give it more detail to the model. And so there we go. Now I cut some from left to right, right to left, but in the end they all show up as oriented from left to right, so that's all we care about. We're going to go to the rivers layer here, and we're going to draw in bank lines. Because we use the effective geometry, those bank stations showed up in kind of all wacky places relative to their spatial orientation. So what we want to do is we're going to go ahead and we're just going to delete these existing, I guess we would call them the duplicate effective bank lines, and we're going to just draw those bank lines in from scratch. So I'm just going to draw very rough, very rough. Please do not judge the way I'm doing this, but they just need to stay on one side of the river line. for RAS mapper to recognize if it's a right bank or left bank station. Okay, so we have those in. We can also draw on flow paths. So if you don't have, if all you have is a river line, HEC-RAS is just going to use the river reach lengths as the left and right overbank reach lengths. But for this case, we may want to use different reach lengths. So I'll just draw in secondary reach lengths here to represent the left and right overbanks. We get this area where flow kind of comes out here, and then it cuts through, and then it probably gets confined more to the channel. And that. If you do have a line that stops, if you just draw another line that connects from two cross sections, it will just take the measurement between whichever line is fully spans two cross sections. And you can draw these from upstream, downstream, downstream to upstream. It doesn't matter. HEC-RAS or RAS mapper will be able to make the correct calculations. So now we've got our flow path lines in. And now what we're going to do with our rivers or our cross sections is we're going to right click on those and we're going to compute some things. We can recompute the river stations, which they've kind of automatically updated. We can compute the bank stations based on those bank lines, the reach lengths based on the flow path lines, and the elevations from the terrain. So we want to compute all these attributes for all these cross sections. If you are only interested in doing that for like one cross section at a time, you can do that. You just need to select a single cross section. Once it's selected, right click, compute, and it will show you that you can select the attributes for this one cross section of the 22 available. So you don't have to globally update all cross sections, and there's reasons why you at times you wouldn't want to do that. So once that's been computed, you can stop your edits. That's going to save your edits. And then we can come to the HEC-RAS main window. We are going to save a plan as the corrected effective plan. And once we've saved the duplicate, oops, that shouldn't have been duplicate, it should be corrected effective. Once we've saved that, again, with any luck, we should be able to run this. We're going to select our corrected effective geometry, and we still want the regulatory flows, so we'll compute it, and we'll get an error that no Manning's values have been set. Okay, so we're going to go into our geometry editor, and all we're seeing is the Manning's values for the duplicate effective cross section. So we're going to set these globally. You could adjust them if you can justify it, but for now we're just going to use the effective Manning's values for all these cross sections. And now we will try running again. And we've had success. So now we can actually go in and compare our results. We're looking right now at our corrected effective profiles. We're going to compare that plan to the duplicate effective. You'll see a mesalliance. We're just going to look at the 100-year for comparison purposes for now. And what you can see is that the corrected effective is a little bit higher in some locations than the duplicate effective, and that could be due to a number of things. It could be due to the constriction and flow that we're picking up, but either way, now we have our corrected effective plan. We can see how that compares in RAS mapper, because we have our corrected effective results that are now showing up. So we can see the difference visually. What we'll do is we'll select our water surface elevation grid for our 100-year, and we still have our 100-year depth grid on. And what you're seeing here is areas where the pink is showing. Those are areas where the corrected effective are wider than the duplicate effective. So you get a good visual representation of where there are differences. You'll notice here's again a straight line here, again due to the edge lines not being set properly, although that doesn't look to be too bad. Okay, for some reason the interpolation surface didn't quite pick that up. I probably should have extended these cross sections a little bit further, but either way, that's where that's coming from. But you can see now we have the results of our corrected effective plan as well as our duplicate effective plan. Last plan we're going to do now is we are going to make our proposed conditions model. So the first thing we need to do to make our proposed conditions model is we're going to make a copy of our corrected effective geometry. We're going to save that geometry as proposed. And what we're going to do is we're basically going to simulate a hypothetical project located right around here. And so once we've created that copy of our corrected effective conditions, next thing we're going to do is we're going to bring in a new terrain data set. And we're going to create this data set by starting with the 2008 LiDAR data. And then we're going to also add in a project site topo file into the terrain layers as well. It's hard to tell from here, but whichever terrain data set you add in last will show up lower on the list. So what we want to do is we want to take this data set and we want to move it up a layer so that it creates a precedence for that data set above the LiDAR. And we're going to name our project proposed topography, so we know which data set we're working with, and we'll let RAS Mapper just create that data set. Now when it's done here, if we turn on this 2008, what we should see here is we've got our new proposed grading here that's happening next to the saline branch. And because we already have our corrected effective layout the way we want to, it's pretty simple from there. We can simply edit our cross sections and we could just update our elevation profiles from the terrain. But before we do that, we have to make sure that now that we have two terrain data sets, we have to make sure that each geometry is associated with the correct terrain. So we're going to right click on the geometries and then we're going to manage our geometry associations. And we can see that our duplicate, effective, corrected, effective, these are all referencing the 2008 LiDAR, which is good, that's fine. The duplicate effective is overridden with effective data anyway. But we want our proposed geometry, we want this to use the proposed topo. So we're just going to do that, save that, and then under the proposed cross sections we're going to compute the elevation profiles from terrain. Now once we've done that, we can stop editing, save. We can come to our HEC-RAS window. We're going to save a plan as proposed. We are going to update the geometry to use the proposed. And again, with any luck, when we hit run, we'll hopefully get something. Again, the Manning's values failed here, so I have to come back in and update our Manning's values. We'll save that, and we will hopefully get this to run. Okay, now we can compare our results again. And what we're looking at here is our proposed profile. We want to look at our 100-year for comparison purposes for LOMRs and CLOMRs. We're going to compare this to the other plans. I want to compare it to the corrected, effective, and the duplicate effective plans. And what we could see here is that our proposed condition, because of that encroachment, because of that grading, that fill placed near the floodplain or in the floodway there, it's going to cause an elevation increase. This is a type of project that would require a CLOMR before it could be move on to the LOMR phase. You'll also notice that there's a difference in the reach lengths here, and you'll recall because we manually adjusted the duplicate effective reach lengths that overall reach is a little bit shorter than the correct effective and proposed conditions reach lengths. But generally here what we're comparing apples to apples, at least when we pull down the elevations from the profile output table. Going back to RAS Mapper, we can also look at our depth grids or our floodplain mapping. You can see this area that where our project is taking place is obviously showing up above the floodplain here because it's simulated basically a bunch of fill in this portion of the floodplain. But then we can also compare this to our corrected effective water surface elevation grid. And wherever here we're seeing that blue depth grid, that's areas where that project has caused an increase in the floodplain. It's caused the floodplain to widen, the BFE to increase, obviously throughout this reach, but we're seeing the impacts of this by comparing the mapping as well. So that's basically it. That's how you can use RAS Mapper to create these 1D models very efficiently, get that spatial component into your modeling, be able to review results on the fly. Even things looking at this, you could see I would look at this and say this is probably an area of ineffective flow because of this constriction here. These are things that you're able to implement into your modeling much more efficiently and effectively when you're doing these types of projects with RAS Mapper, because you can see your results as soon as you implement them into your model, and it just makes modeling a lot more efficient, and especially for LOMRs, being able to do those comparisons, I think it's a real handy tool. So that's all I had for the modeling demonstration. Hopefully you're able to learn something from that, and we'll take some questions here at the end. Thanks.
All right, well, thank you, Chris and Brian. It was definitely really informative. I know there's been a few questions that have been sent through the group chat, and it looks like for the most part, Chris and Brian provided some good answers and some other resources to those questions. At this point, we're going to open it up if anyone else has any other questions, or if Brian, Chris, if there's anything else you guys want to add, feel free to speak up. If anyone else, you can unmute yourself if you want to ask a question, or feel free to send it through the chat if you have any questions. Definitely a lot of information, like Megan mentioned. So, Megan, did you have a specific question? Oh, it looks like, sorry, they answered your question. Did anyone else have any other questions at this point?
It's a great group. The chat worked really well, I think. Hopefully.
Yeah, and I'm also curious to hear what people think of this format as far as recorded versus totally live. I think that they make it easy for discussion. Oh, it looks like Emily Jenkins did have one question. Is a RAS map appropriate to submit for the LOMR CLOMR for the topographic map?
Hey Emily, this is Chris, and yeah, I would say it provides a lot of the good starting blocks for that. I mean, you've got your terrain in there, you've got your contours, you've got your various mapping layers in there. I personally might take it out to another GIS or CAD-based program to finalize that. It seems like RAS Mapper, while it can do a lot of things, it's not set up to create those plan sheets or title blocks, things like that, that you would want to include on a nice finished exhibit. So I would probably use that to create my layers and then use a different software to finalize the work map.
Yeah, we have to upload a work map as part of the requirements for the processing the case at the end of the case when we're ready to issue. From a practical standpoint, having a georeferenced RAS model is probably more helpful to anybody that's going to pick it up in the future. But yeah, we're going to have something like that. And I don't think we could just do a screenshot. Chris, do you turn a screenshot into a PDF and call it good? I mean, things, there's supposed to be a bunch of stuff. Yeah, the work map's got to include, okay, things like what datum is this on? And there's a number of requirements that work maps. We put out our laundry list of make your work map do this. So RAS Mapper's not quite set up to do that yet.
And Brian, just a follow up to that, and assuming all of the, and Chris too, assuming all of these layers, everything that's created within RAS Mapper can be easily exported through shapefiles or other formats out to GIS and other tools.
Yeah, we typically work in GIS because a lot of the work that we ultimately do through map revisions has to fit in the FEMA database for floodplain mapping. So FEMA relies heavily on ArcGIS tools and software to implement their national flood hazard layer. So that's the end product that we have to get to. So we're constantly working in GIS, but I know a lot of engineers and consultants are working in CAD or MicroStation, other programs. So I haven't experimented with bringing data into CAD, for instance, from RAS Mapper, but I would think there's a way to do it.
Yeah, and I think as long as you have a shapefile, you can pretty much get it into any software that has some type of georeference frame. So that would probably work with CAD-based softwares.
We were just talking this morning about how to bring the exported RAS Mapper delineations and cross sections, everything into our final work maps rather than going through ArcMap and redoing everything in ArcMap, all our delineations. We've worked that process out quite a long time ago, but RAS Mapper is doing pretty well. We're going to do some comparisons with our process and the RAS Mapper process, try to identify some of the potential glitches that RAS Mapper has shown a little bit, especially as you extend those edge lines out pretty far. Sometimes that interpolation surface gets a little odd. So we've seen some problems with the resulting raster, but it kind of shows itself, I guess, as big streaks across the raster. So you know you have a problem.
All right. Any other questions for the speakers at this point? It's like, and just to Evan, to answer your question, so we will definitely send out a link to the pre-recorded presentation, and we'll get all the other information that was provided within this meeting. Typically, we save that on the IAFSM website. So once we get that uploaded to the IAFSM website, I'll be sure to send that out. Also, along with a PDH certificate to any attendees. And we're also going to send out a survey for just to get some feedback on the presentation and the format and any other potential topics that anyone's interested in. Definitely appreciate if you guys can fill that out if you have some time, because that helps us to refine and to know exactly what topics or people are interested in. I know HEC-RAS is definitely a topic that is interesting to a lot of us and important as far as our job responsibilities. So this is definitely a very relevant topic. And if there's any other follow-up topics related to HEC-RAS or LOMRs or anything of that sort, please definitely mention that in the survey, or feel free to email me directly, and we'll try to, if Brian and Chris are interested in the future, potentially have them for a different topic. I know there was some discussion about some getting topo survey, putting that together, but I think Brian provided some resources for that. So I guess at this point, I'd like to thank Brian and Chris for their time and effort, and we definitely appreciate it. And thank you everyone for coming. And we do have, we're working on setting up our next webinar for likely early August. So stay tuned. We'll try to get the details out in the next few weeks. But thank you again for everyone coming, and hope you all have a good day.
Thanks, Adam.
Yeah,
Take care,
thanks,
everybody.
guys.
Thanks.